Hello everyone. Today we'll be discussing about distribute your services across Azure virtual networks and integrate them by using a virtual network peering. This is a continuation to our last series. So we were discussing about AZ104, configure and manage virtual networks for Azure administrators. Let's get into the chapter. Let's start. So this has units, 3 exercises, one introduction and one more summary. Exercise windows are open, so we'll go through the introduction very first. Imagine you are the solution architect for an engineering company that has been migrating services into Azure. The company has deployed services into separate virtual networks but has yet to configure private connectivity between them. Several business units have identified services in these virtual networks that need to communicate with each other. You need to enable this connectivity, but you don't want to expose these services to the internet. You also want to keep integration as simple as possible. Okay, identify use cases for virtual network peering. Identify features and limitations of virtual network peering. Configure peering connection between virtual network. Connect services using virtual network peering. The next unit. Okay, that will be theory 1. You can use virtual network peering to directly connect Azure virtual networks together. When you use peering to connect virtual networks, virtual machines in these networks can communicate with each other as if they are in the same network. With peered virtual networks, traffic between virtual machines is routed through Azure network. The traffic is only private IP addresses. It doesn't rely on internet connectivity, gateways, or encrypted connections. The traffic is always private and takes advantage of high bandwidth and low latency of the Azure backbone network. Two types of peering connections are created in the same way: virtual network peering, global virtual network peering. They are in the same Azure region, such as two virtual networks in North Europe. Virtual networks that are in different region, this is global virtual network peering, such as virtual network in North Europe and virtual network in West Europe. Virtual network peering doesn't affect or disrupt any resources that you have already deployed to the virtual networks. Okay. Reciprocal connection. When you create virtual network peering connection with Azure PowerShell or Azure CLI, only one side of the peering gets created. To complete virtual network peering configuration, you will need to configure the peering in reverse direction to establish connectivity. When you create virtual network peering connection through Azure portal, the configuration for both sides is completed at the same time. Exactly. Think of how you would connect two switches together. You would connect cable to each switch and maybe configure some settings so that the switches can communicate. Virtual network peering requires similar connection in each virtual network. Reciprocal connections provide this functionality. Cross subscription virtual network peering. You can use virtual network peering even both virtual networks are in different subscription. This setup might be necessary for mergers and acquisitions, or to connect virtual networks in subscription that different departments manage. Virtual networks can be different subscriptions, and the subscription can use the same or different macro and tenants. When you use virtual network peering across subscription, you might find the administrator of one subscription doesn't administer the peer network subscription. The administrator might not be able to configure both ends of the connection. To peer the virtual networks, when both subscriptions are different Microsoft tenants, the administrator of each subscription must grant the peer subscriptions administrator the network contributor role in their virtual network. Okay. Virtual network peering is non-transitive. Only virtual networks that are directly peered can communicate with each other. Virtual networks cannot communicate with peers of the peers. Yes. Suppose example that your virtual networks ABC peers like A to B, B to C. Resources in A cannot communicate with resources in C because the traffic cannot transit through virtual network B. If you need communication between virtual networks A and virtual network C, you must explicitly peer these virtual networks together. Gateway transit. You can connect to on-premises network from peered virtual network if you enable gateway transit from virtual network that has VPN gateway. Using gateway transit, you can enable on-premises connectivity without deploying virtual network gateway to all your virtual networks. This method can reduce overall cost and complexity of your network. By using virtual network peering with gateway transit, you can configure a single virtual network as hub network, connect this hub network to your on-premises data center, and share the virtual network gateway with peers. To enable gateway transit, configure the Allow Gateway Transit option in the hub virtual network where you deployed the gateway connection to your on-premises network. Also configure the Use Remote Gateways option in any Spoke virtual network. Allow gateway transit in the hub network, use remote gateways option in the Spoke network. If you want to enable use remote gateways option in Spoke network peering, you cannot deploy virtual network gateway in Spoke virtual network. Overlapping addresses. IP addresses space of connected networks with Azure between Azure and on-premises network cannot overlap. This is also true for peered virtual networks. Keep this rule in mind when you are planning your network design. In any networks you connect through virtual network peering, VPN or express route, assign different address spaces that don't overlap. Alternative connectivity methods. Virtual network peering is the least complex way to connect virtual networks together. Other methods focus primarily on connectivity between on-premises and Azure networks rather than connections between virtual networks. You can also connect virtual networks together through an express route circuit. Express route is a dedicated private connection between on-premises data center and Azure backbone network. The virtual networks that connect to an express route circuit are part of the same routing domain and communicate with each other. Express route connections don't over the public internet, so you communicate with Azure services as secure as possible. VPN use the internet to connect to your on-premises data center to Azure backbone network through an encrypted tunnel. You can use site-to-site configuration to connect virtual networks together through VPN gateways. VPN gateways have higher latency than virtual network peering setups. They are more complex and can cost more to manage. When virtual networks are connected through both gateway and virtual network peering, traffic flows through the peering configuration. When to choose virtual network peering? Virtual network peering, a great way to enable network connectivity between services that are in different virtual networks, because it is easy to implement and deploy, and it works well across regions and subscriptions. Virtual network peering should be your first choice when you need to integrate Azure virtual networks. Peering might not be your best option if you have an existing VPN or express route. Connections are services behind Azure Basic Load Balancer that would be accessed from peer virtual network. In these cases, you should research alternatives. Exercise. Prepare virtual networks for peering by using Azure CLI commands. This is an exercise, right? I have prepared already. Virtual networks for peering by using Azure CLI commands. Sales virtual network is deployed in North Europe. Marketing in North Europe. Sales system use this virtual network to process the data that's added for customer is engaged. The sales team wants to access marketing data. Marketing systems use this virtual network. Members of the marketing team regularly chat with sales team to share their data with the sales team. They must download it because the sales and marketing systems aren't connected. Virtual network is deployed West Europe. Research virtual network uses this virtual network. The members of the research team have logical working relationship with marketing, but they don't want sales team to have direct access to their data. North Europe, West Europe, sales, marketing, research. So we'll create this sales unit, marketing unit, research unit. It will have app subnet and this data subnet address 110.24.210.310/24. So in Cloud Shell, run the following commands to create virtual network for sales system. happened, man? One out of 10 sandboxes. Let me see this again. The scope is invalid. If your access was recently granted, please refresh your credentials. What should we do then? I'm refreshing the page. Sandbox activated. Copying it. So virtual network and subnet for marketing system. So this is for sales system we'll be giving, and then marketing, and then we'll be creating research and related subnets. In Cloud Shell, run the following command to view virtual networks. So we'll be listing the virtual networks once we create all these three. Let me see this. This is a... I don't understand what's happening. Wait. I did AG login. Let's see it will work or not. I'll continue it from here. I don't think it will work this time as well. The client with object ID does not have authorization to perform over this. Quit. I quit from here. On this. We have 3 of 10%. We use 3 sandboxes. Let's see. Yeah, that's fine. We have some problem with the Cloud Shell, so we are creating virtual networks, marketing, sales, and research. 3 will be created, and then we'll list the virtual networks. It will display like this: 1, 2, 3. So create virtual machines in each virtual network. Using this VM create command, we create virtual machines. Virtual name is virtual machine name is sales VM. And the virtual machine name is marketing VM, and the virtual machine name is research VM. Okay, to confirm that VMs are running, run the following command. We'll be watching with this command. So succeed. When the VMs are running, you are ready to move on to press Ctrl C to stop and the command and watch. Continue on the exercise. So we just created 3 VMs and 3 virtual networks. Then we'll continue on to the next exercise. So yeah, this also didn't work for us. Uh, so here in Cloud Shell, run the following command to create peering connection between sales and marketing VNet. So network VNet peering create sales VNet to marketing VNet. So reciprocal connection also we are creating by running this command marketing to sales VNet. Sales and marketing create connections between marketing and research. So marketing VNet to research VNet will be creating peering, and the reciprocal connection will be creating. So we'll check the connection by listing the VNet peering list here, and you have created only one connection from sales VNet, so you get only one result. In the peering state column, make sure its status is connected. Run the following command to check peering connection between research VNet and marketing VNet. Again, you have created only one connection from research VNet to, so only get one result. Peering state column, make sure status is connected. Run the following command to check peering connection for marketing VNet. Remember that you created connections from marketing to sales and from marketing to research, so you should get two connections in peering state column. Make sure status of both connections is connected. Your peering connections between the virtual networks should now look like this: sales to marketing, marketing to research. Check effective routes. You can further check the peering connection by looking at the routes that apply to the virtual interfaces of the VM. Network interfaces show effective route table. The output table shows the effective routes for the VM's network interfaces. The sales VM NIC should have the route 10.20.06. What is that? With the next hop type VNet peering, this is the network route for the peering connection from sales VNet to marketing VNet. Sales VM into marketing VNet. Look the routes that apply to the sales VM network interface. Sales VM network interface. The output table shows the effective routes for the VM's network interface. For sales VM NIC, okay, you should have route with next hop VNet peering. Okay, this is type of VNet peering. This is the network route for peering connection between sales VNet to marketing VNet. Routes for marketing VM. So this is VNet peering 10.1.16. Next type of global VNet peering 10.30. Okay. Run the command to look for the routes of research VM. This is for VNet peering. Global peering 20.00.16. Now that your peering connections are configured, let's take a look at how affect the communication between VMs. Let's continue. In the previous unit, you configured peering connection between the virtual networks to enable resources to communicate with each other. Your contribution used a hub and spoke topology. Marketing VNet has the hub, and the sales VNet and research VNet are spokes. Yes. Remember, peering connections are non-transitive. Intermediate virtual networks don't allow connectivity to flow through them connected to virtual networks. Sales VNet can communicate with marketing VNet. Research VNet can communicate with marketing VNet. Marketing VNet can communicate with both sales and research VNet. The only communication that's not permitted between sales VNet and research VNet. Even though sales VNet and research VNet are both connected to marketing VNet, they cannot communicate with each other because they are not directly peered to each other. Let's confirm. Let's confirm the connectivity across peering connections. To do this, you will create a connection from Azure Cloud Shell to target VM's public IP address. How? Let's confirm the connectivity across peering connections. To do this, you will first create connection from Azure Cloud Shell to target VM's public IP address. Then you will connect the target VM to the destination VM by using destination VM's private IP address. To connect your VMs, you will use SSH directly from Cloud Shell. When using SSH, you will first find the public IP address that are assigned to your test VMs. In Cloud Shell, run the following command: list IP addresses you will use to connect the VMs. Resource group, learn this query name, private IP, public IP, show the details. Record the output. You will need the IP addresses of the exercise in this unit. Before you start the test, think about what you have learned in this module. What results you do expect, which VMs will and won't be able to communicate with each other. Test connections from sales VM. In the Cloud Shell, run the following command using SSH to connect the public IP address of sales VM. In the command, replace sales VM IP address. So SSHO will be connecting. Cloud Shell connects to sales VM and then it will connect to marketing VM. Okay, sign in with password that you used to create the VM. Prompt now shows that you are signed into sales VM. In Cloud Shell, run the following command using SSH to connect to private IP address of marketing VM. Yes, it will be connected. The connection attempt should be succeed because peering connection between sales VNet and marketing VNet virtual network. Sign in by using the password used to create the VM. Enter the exit, close this SSH session and return to sales VM. In the Cloud Shell, run the following command using SSH to connect the private IP address of research VM. So we will be connecting to research VM. So the connection attempt should fail because there is no peering connection between sales VNet and research VNet. Yes, exactly. It will fail. Enter exit, close SSH connection, return to Cloud Shell. Test connections from research VM. In the Cloud Shell, run the following command. So now Cloud Shell will connect to research VM and then it will connect to marketing VM. It will be successful and then it will try to connect to the sales VM. It will fail. So test connections from marketing VM. From marketing VM, it will connect to this VM and this VM as well. This is a simple test using SSH. It demonstrates network connectivity between peer virtual networks. It also demonstrates lack of network connectivity with transitive connections. If these servers were running application services, the server's connectivity will allow communication between the services running on the VMs. The connectivity would allow the business to share the data across departments as required. Let's go to the summary. So now that you understand how to peer virtual networks together, you can use this cost-effective and minimal complex method in Azure network infrastructure. The method enables low latency communication between resources in virtual networks. It supports scenarios where resources are in different regions or subscriptions. Virtual network peering should be your first choice when you need to connect virtual networks. Yeah, thanks for watching this video. We will connect in the next session. Until then, bye bye.